Welcome to this video in which we together are going to solve an entire past paper of the AS Maths P1. On my website explainingmaths.com I was asked to do this for you, so of course I'm willing to help you out. Please like and share if it was useful, guys, because it takes a lot of time to do it, so that would be very kind of you. But before we start, we have to realize that all the credit goes to the Cambridge examination, because this is their work. We're just here together to solve the questions and help each other out to understand maths better. So we're going to do exam 13 of May-June 2015, and we have 1 hour and 45 minutes to complete. Make sure that you give all non-exact answers correct to 3 significant figures or 1 decimal place in case of an angle. Yeah? So please have a good read of that cover page. So let's start with question 1. So question 1, it says express 2x squared minus 12x plus 7 in the form a bracket x plus b squared plus c, where a, b and c are constants. Good. There are 2 ways you could do this for 3 points. It's a nice question to start with. There are 2 ways of doing this particular question. First of all, and I'll show you both, why not? First of all, I could expand that expression. So what will I get? I'm going to say a, and then I'm going to expand the 2 sets of brackets. So that's x squared plus bx, so that's plus 2bx plus b squared plus c. So you'll have ax squared plus 2abx plus ab squared plus c. Alright, and then I'm going to compare what I have here with the initial expression, and let me write that underneath. So you have 2x squared minus 12x plus 7. Alright, well, I only have 1 term in x squared here, that's here, so that means that a has to be 2. So I can say a equals 2. Now what about b? Well, 2ab has to be minus 12, so 2ab has to equal minus 12, and if a is 2, that means that 2 times 2, 2a, so 4b has to be minus 12, so b has to be a minus 3. There we go. Then we look at that last part, that ab squared plus c, that is the constant, that is a number that has to equal 7, so ab squared plus c has to equal 7. You know the values of a and b, so we substitute that. Minus 3 squared is 9 times 2, so it says 18 plus c equals 7, so c will be a minus 11. So your final answer then will be 2 bracket x plus b, so x minus 3 squared minus 11. There you go. Now you could also have done it with by completing the square. Let me do that very quickly. So I take out the 2. There's several ways of doing this, by the way, but this is how I do it. X squared minus 6x plus 7. And then I'll try to turn it into a perfect square. So I divide the minus 6 by 2, so you're going to get x minus 3 squared plus 7. But if I now would expand this set of brackets, I would get x squared minus 6x plus 9. So I got to get rid of that plus 9, but that plus 9 you will also multiply by 2, so plus 18, and to get rid of that I need to subtract it by 18 here, otherwise it wouldn't be the same. Yeah, so if I would simplify that, there you go, it's going to say exactly the same as what I got here. So you choose whatever method you think is best. Okay, explainingmaths.com for more information. Let's move on to question 2. So we've arrived at question 2 now, and we're still solving the entire AS level maths paper. What's going on? It says a curve is such that dy dx equals 2x plus 1 to the power a half, and the point 47 lies on the curve. Find the equation of the curve. Good, so they give us the derivative, and then to find the equation of the original curve we have to integrate the derivative, and then we'll find the original function. So then fx is going to be, I'm just going to leave some space there. I'm going to put those brackets there, because if you like, you're going to use the reverse chain rule. That half, that becomes 1 more, because if you find the derivative, you always take 1 away. So for the integral, you add 1, so that will become 3 over 2. But then we have to multiply the whole set of brackets by 2 over 3, the reciprocal, if you like, of 3 over 2, because there's a 1 there. So 3 over 2 times 2 over 3 is going to give me my 1. But I also have to multiply it by 1 over 2, which is derivative on the inside. Yeah, so make sure to check my site explainingmaths.com, where I will explain integration in more detail. But if I'll have to simplify that, but I have to say there plus c, because there could be this, or plus k, there could be this constant there at the end, which cancels out if you find a derivative. Okay, so let me simplify that. Fx equals 2 over 6, so 1 over 3, 2x plus 1 to the power 3 over 2 plus c. But they give me a boundary condition. They give me this particular point, 4, 7. I'm going to use that point now to find the value of c. So when x is 4, y is 7. So you're going to plug those values in. 2 times 4 is 8, plus 1 to the power 3 over 2 plus c. So 8 plus 1 is 9, to the power 3 over 2. That is 27, divided by 3 is 9, and then 7 minus 9, c will be minus 2. There you go. So the original function, the function or the equation of the curve will be fx, or y equals 1 over 3, 2x plus 1 to the power 3 over 2 minus 2. There you go. Please like and share if this is useful, guys. Let's go to the next question. Question 3. So we've arrived at question 3, which says, write down the first 4 terms in ascending powers of x. So starting with the smallest power and then finishing at the highest power of the expansion a minus x to the power 5. And then we have to solve the second question, the coefficient of x to the power 3 in the expansion of 1 minus ax times a minus x to the power 5, which is the same one, is minus 200. So they give the coefficient, find the possible values of a. Good, let's start with the first one. Only the first 4 terms, because if you would expand this, you'll have 6 terms, but you only have to do the first 4. And I like to use Pascal's triangle for that. So I'm just going to write quickly just a part of that, 1, 2, 1. And so Pascal's triangle is going to give you part of that coefficient if you expand it. And I'm going to, because it's to the power 5, I'm just going to write down the first 1, 2, 3, 4, 5 rows, because I'm going to use these numbers now, 1, 5, 10, 10, 5 and 1. Good, the first 4 terms. So what I like to do is to put some dots there. Term 1 plus term 2 plus term 3 plus term 4. Yeah, maybe you have a different approach. That's fine. Please use your approach. So the first term is going to be a, just a to the power 5, and then minus x to the power 0. So it's the lowest power of x, and that is 1, times that number times 1. So yeah, if you have a little bit more experience, you know that that first one is going to be a to the power 5. Then that second term, I'm going to put that number of Pascal's triangle there, 5 times a to the power 4 times, what is it, minus x to the power 1. Those indices have to add up to 5 all of the time. Putting it in brackets because it's minus x, yes, I don't want to make a silly mistake at some stage. The third term is going to be 10 times a to the power 3 times minus x to the power 2. Again, those indices add up to 5. And the fourth term, 10 a to the power 2 minus x to the power 3. Yeah, and of course it continues, but we only have to do the first 4 terms. So if I simplify that, we are going to get a to the power 5 plus, no, not plus, can I take that away? Minus, there we go. So a to the power 5 minus 5a to the power 4x plus 10a to the power 3x squared. Why plus? Because it's minus x squared, so you lose that negative. And then again, minus 10a squared x to the power 3. And I'll just do plus to show that I understand that there are more terms, but we only have to write down the first 4. Good, that was for 2 points. Now usually that is followed by the next question. The coefficient of x3 in the expansion of is minus 200. Find the possible values, yeah, so more than one of the constant a. Now what I really like to do is to write down that expansion. So you have 1 minus ax and then to write down those terms that I found for question A, because I'm going to use them now. So I'm going to write it down, because that makes it easier for me to see when I will get a term in x to the power 3. A squared x 3 plus, and I'll just put some dots there. So when will I get a term in x to the power 3? That is when I do 1 times a term in x to the power 3. So that is 1 times that term. So I do not have to expand the entire thing. No, I will get a term in x to the power 3 if I do 1 times minus 10a squared x to the power 3. So that would be minus 10a squared x to the power 3. Is there going to be another term in x to the power 3 if I multiply it by 1? No, there is not. However, you'll get another term in x to the power 3 if you multiply that second term by another term in this set of brackets. This is x. So to get x to the power of 3, I have to multiply it by x squared. Yes? So if I do minus ax times that term, so that's going to be then, let me see, minus 10a to the power 4 x to the power 3. That also will give me a term in x to the power 3. So those will be my 2 terms in x to the power 3. And they tell me, well, the coefficient is minus 200. So if I would add those 2 terms, minus 10a squared minus 10a to the power 4, that should equal minus 200. Okay, I can divide everything by minus 10 just to make my life easy. So a to the power 4, I will write the highest power of a first, plus a squared, let me see, minus 20 equals 0, because I'm going to equal it to 0 straight away. Now this is an equation in a to the power 4. How can I solve it? Well, I can write down, let's just imagine that a to the power 2 is the same as a. Then that first term will be a to the power 2 plus a minus 20 equals 0. Okay, so I'm manipulating the equation now because I do know how to solve quadratic equations. So I'm saying, well, a squared is going to be a. So a to the power 4 therefore becomes a squared, and a squared then becomes a. Okay, and at the end of this question, I will take care of that again. How do I solve a quadratic? I can factorize it. So if I can continue, where shall I continue? I'll continue here. So it will be a, what is it, plus 5, a minus 4 equals 0. So a can be minus 5 or it can be 4. So a can be minus 5 and a can be 4. However, we said that a is a squared. So that means that a squared can be minus 5 or a squared can be 4. Now we cannot take the square root of a negative, so I can cancel out this solution. So if a squared is 4, then a can be plus or minus 2. Does that say minus 2? I don't think you can see that on your screen. So a is 2 or a is negative 2. So those are your 2 solutions for a. They already said find the possible values of the constant a. Excellent. Explainingmaths.com, guys. We're solving the entire A as past paper. Let's move on to the next question. So let's solve question 4 together now, which is a question about trigonometry and identities as it appears. Express the equation 3 sine of theta equals cosine of theta in the form that tangent theta equals k, a particular constant. And solve the equation, so don't forget that, and solve it for theta between 0 and 180 degrees. Well, you should realize that the tangent of any angle, that's the identity, is the sine of that angle over the cosine of that angle. So what could I do? I can say, well, 3 sine theta equals cosine theta. I'm going to divide both sides by the cosine of theta, because then on the left side, what do I have on the left side? I'll have 3 times sine theta over cosine theta, which is the tangent. So it says 3 tangent theta equals, so what is the cosine of theta over the cosine of theta? That will be 01. So the tangent of theta is going to be 1/3. And if I grab my calculator now, and because I also have to solve it, I do the inverse shift tan of 1/3, and that equals let me see, 18.4. Is that correct? Let me just check that again. Shifts, tan, answer, 18.4. Yes, there you go. To one decimal place, 18.4 degrees. Good. Now moving on to the second part of question 4, it says solve the equation 3 sine squared of 2x equals cosine squared of 2x for 0 to 180 degrees. And of course this is a different equation than the equation for part A, however there is a relationship. They're almost the same. What's the difference? Well, it's theta here and 2x there, and it's a sine and a cosine in part A and sine squared and cosine squared for part B. But you can say, therefore, and I'm going to put that in this corner, I'll just put a line here, there we go. You can say that then the tangent squared of 2x has to equal a third. We've just said that we showed that the tangent of theta is a third. Now everything is squared, 2x, so that still is a third. That means that the tangent of 2x will be the square root plus or minus the square root of a third, which is, what is the square root of 1? That is 1 over the square root of 3. There we go. Then before I continue, I've got to do something with this 2x over here. So I have to say, well, 2x, I will call that, for instance, alpha or theta or beta, whatever you want to call it. But then, as a result, also the domain will change. So if we say 2x is alpha, then the domain will go from 0 alpha to twice as large, so to 360 degrees. Okay, first let's have a look at those positive values. So we're going to have a look at the tangent of alpha when it is 1 over the square root of 3, and the positive values, and then we're going to have a look afterwards at the tangent of alpha when it is a minus 1 over the square root of 3. So if you plug this in your calculator, shift tan the inverse 1 over square root of 3, it's going to give you 30 degrees. And I always like to then make a sketch of the unit circle. There's several ways of doing this, but I prefer the unit circle. And I say, well, so at 30 degrees, that's going to be one of my solutions. Let's write it down, 30 degrees. But you have another solution where the tangent will have that particular value, which is on the other side. But your calculator does not give to you that particular value. Now you need to find it. And that value is going to be 180 plus 30. So that will be 210 degrees. Good. So those are your two values for the positive 1 over the square root of 3. You're going to do the same for shift tan minus 1 over the square root of 3. And then your calculator is going to say minus 30. So that will be on this side, minus 30. But our domain is between 0 and 360. So I cannot take it at a negative angle. However, I can take it in the positive direction. So what is the size of this angle? That will be 360, a full turn, take away the 30, so that will be 330. So let me write that one down, 330. And then also you realize I have another value on the other side for the tangent, which is going to be 180 minus 30, which is 150 degrees. There you go. So those are your four values. Now, very last thing you need to do, and that's why you get 4 points, guys, because there are a few things to consider. These are the values when you say for alpha, and alpha is 2x. So if 2x are those values, then we're interested in x, and we're trying to solve the equation, then we have to take half of them. So 15 and 110, not 110, sorry about that. What is 210 divided by 2? It's 105 degrees. 105 degrees. 330 divided by 2, 165 degrees and 75 degrees. So I had to divide all those angles by 2 because I said 2x is alpha. Then I solved for alpha. As a result, the domain changed. I find my 4 values, but I got to divide them by 2 because of that. Excellent. Like and share, guys, if this is useful. explainingmaths.com. Let's go to question 5. So, time for question 5. A question about vectors. They say, relative to an origin O, the position vectors of points A, B, and C are given. And those are the 3 position vectors. Show that the angle ABC is 90 degrees, 4 points. So we have to show that it is a perpendicular angle. Now what I always really like to do, but that's completely up to you, I just like to make sort of a sketch. These are three-dimensional vectors. I just like to make a sketch OA 3, 2, minus 3. Let's say it's there. So that is 3, 2, minus 3. OB 5, minus 1, minus 2. So let's say that's there. Sorry, I have to put an A there. B is 5, minus 1, minus 2. And C 6, 1, 2. Let's say it is roughly there. So you don't have to be accurate with this. This is just for myself. So I have this triangle, and then they tell me that ABC, so this angle is perpendicular. Now because it's a three-dimensional drawing, it doesn't look perpendicular and it's a horrible sketch, but it does show me that I need to look at the following two vectors. I need to look at vector AB and vector BC. So I'm going to find vector AB. How can I go from A to B, vector AB? Then I take OB, so 5, minus 1, minus 2, and I subtract it by vector OA 3, 2, minus 3. And why do I do that? Because to go from A to B, I have to go back to the origin and then to B. So it's negative OA plus OB. That's what we're doing here. And if you do that properly, what is that? 5 minus 3 is 2, minus 1 minus 2 is minus 3, minus 2 minus minus 3. Which will be 1. Okay, there we go. So that is AB. We need to do the same for BC. So BC equals, and a similar thing, what is BC? Well, then we have to go back from B to O, so minus OB plus OC. So OC is going to be 6, 1, 2. Take away 5 minus 1 or minus 2. There we go. So what is that? That is going to be 1, 2, 4. Yeah, so take care of those negative signs. A negative negative makes a positive. Fantastic. Now when are two vectors perpendicular, then you have to take the scalar product. The scalar product has to be 0. So you could say, have to show you're working at AB dot there BC, that has to be 0. So let's check that out. So we have 2 minus 3, 1 dots, 1, 2, 4. And if we work that out, it is 2. Let me put a proper line there. It's 2 times 1, 2 times 1, which is 2. And then we have minus 3 times 2, which is minus 6. And we have 1 times 4, which is a positive 4, and that indeed is 0. So it is perpendicular. Yeah, you can say, therefore, ABC is perpendicular or 90 degrees. There we go. So that's the first question. The second question, find the area of triangle ABC. Now you know it's a right angle triangle, so how do you find the area of a right angle triangle? I'll squeeze it into this corner. That is half times base times height. And the base and the height make the angle of 90 degrees. Yeah, so I need to find the size of this vector, the size of vector AB. Now what is the size of vector AB? So the size of vector AB, that is the square root of 2 squared plus minus 3 squared plus 1 squared. Yeah, so I'm looking at the vector AB now. That will be, what is that, 4, 13, 14, square root of 14. There we go. And AB, and what about BC? Again, those are the two lengths that create a perpendicular angle. So BC, what is the size, the magnitude of BC? That will be the square root of 1 squared plus 2 squared plus 4 squared, 16, 20, 21. So the square root of 21. There we go. So how do we find the area of the triangle? So that's half times the square root of 14 times the square root of 21, which equals 8.6, I believe, to 1 decimal place. Yeah, so let me just check that if that is correct. So we do the square root of 14 equals times the square root of 21 equals divided by 2. 8.6, correct to 1 decimal place, so make sure you round it properly. Excellent. Please like and share still, guys, if this is useful. Check my website explainingmaths.com, and let's move on to question 6. So we've already arrived at question 6 now, and we're still solving the entire past paper of the AS level maths, and you can check my website explainingmaths.com for all my free resources. Now, what's going on? The diagram shows the graph of the inverse function, where f, the inverse, is defined by 1 minus 5x over 2x between 0 and 2. So this is the inverse of a particular function. Find an expression for the actual function and state the domain. Okay, very interesting question, I have to say. How can you find the original function looking at its inverse? You can take the inverse of the inverse, if that makes sense. Let's just write it down, I'm sure it does. So if y equals 1 minus 5x over 2x, the inverse of the inverse, so you swap x and y, it's going to say x equals 1 minus 5y over 2y. So we've swapped x and y, and now we're going to make y the subject of this equation. So we will multiply both sides by 2y. So I have 2yx equals 1 minus 5y. I move the minus 5y to the left, so it says, if I continue here, 2yx plus 5y equals 1. I have two terms in y. Again, I have to make y the subject. It should say y equals and then the rest. Two terms in y, so I have to factorize that. 2x plus 5, and then I can divide both sides by 2x plus 5. So 1 over 2x plus 5 is the original function. So again, looking at an inverse, to find the original function, you take the inverse of that inverse. But now the domain. The domain of the original function is the same as the range of the inverse function. Okay, so if I find the range of the inverse function, that will be equal to the domain of the original function. Now, so the range being the possible y values. And as you can see, those y values there, as x approaches 0, those y values go up till infinity. Okay. But what is happening here? So what is the y value here? Please note, by the way, that the domain for the inverse is between 0 and 2. So what is the y value there when x is 2? Let's just find that out. So it's going to be 1 minus 5 times 2 over 2 times 2, which is negative 9 over 4. So what is the range of my inverse? The range is y is bigger or equal to negative 9 over 4, because that's the smallest y value, and it just goes up till infinity for the range of the inverse, and that will be the domain of my actual function. So the domain of the original function, the domain x is bigger or equal to minus 9 over 4. Fantastic. Let's move on to the second part. The function g is defined by 1 over x for x bigger than 1. We have to find the composite function, giving your answer in the form ax plus b, where a and b are constants to be found. Okay, so the composite function, I have to put the function g inside the inverse for x. So it is going to say 1 minus 5 times x, so 5 times the function g, which is 1 over x, over 2 times x, so 2 times 1 over x. And if I simplify that, I have 1 minus 5 over x over 2 over x. And if you we have to write that in this form, so we have to manipulate it, and then instead of dividing by the fraction, we can multiply it by the reciprocal. There we go. So x over 2 times 1 is x over 2, or a half x if you like, and x over 2 times minus 5 over x is minus 5 over 2, or minus 2.5, whatever you prefer. Excellent. That was that question. Let's move on to question 7. So this question is about coordinate geometry, and it says the point A has coordinates P1 and point B has coordinates 9, 3p plus 1, where p is a constant. Okay, what's going on? For the case where the distance AB, so from A to B, is 13 units, find the possible values of p. Now, how do we find the distance between 2 points, or the length of a line segment? That is with Pythagoras. So Pythagoras, a squared plus b squared equals c squared. Now, what is the distance? What is the distance from p to 9? That is going to be 9 minus p, and then you have to square that. And what is the vertical distance from 1 to 3p plus 1? That is going to be 3p plus 1 minus 1 squared. And that equals apparently 13 squared. And we're going to find the value of p. I'm going to get 13 out of the question. So I'm going to expand this 9 times 9. 81 minus 9 minus 9p, so that's going to be minus 18p plus p squared. And before I expand this one, I'm going to simplify that. I'm just going to cheat now. I'm just going to do it like that. 1 minus 1 is 0, so it's just going to say 3p squared. Please, you make sure you write down all your workings. But I'm not. 3p squared, ladies and gentlemen, is 9p squared. Don't forget to square that 3 equals 169. So they're telling me the possible values of p, by the way. That's important. So more than 1. And that makes sense now because I have a quadratic equation, as you can see. And then you have more than one solution most of the times. 10p squared, let's put it all in order. Minus 18p, 81 minus 169, that will be minus 88 equals 0. Can I just check that? That's been a long day for me. 169, no, I should do 81 minus 169. Come on, 81 minus 169 equals minus 88. Great. I'm not going to factorize this. I will plug it in my calculator to find, you can use the ABC formula, or the quadratic formula, I should say officially, where A is 10 equals B equals minus 18 equals, and C equals minus 88. And I'm going to get my values for P, which is 4 apparently, so P can be 4, so I could have factorized it, I guess. No, well, minus 2.2. And minus 2.2, or minus 1 over 5. Excellent. The second question for 4 points, for the case in which the line with equation 2x plus 3y equals 9 is perpendicular to AB, find the value of p. Okay, so we have this line perpendicular, and I always, and you have to in this case, want to write it in gradient intercept form. So I'm going to rearrange it, and then I get minus 2 over 3x plus 3. Okay, so it has to be, this line is perpendicular to the line AB. And when it's perpendicular, then what can you say about the gradient? It's always the negative reciprocal, isn't it? So the gradient of AB, so the gradient of the line AB is going to be 3 over 2. So dy dx for AB is going to be 3 over 2. Now what is dy? So the difference in the y direction, that could be 3p plus 1 take away 1, and the difference in the x direction is 9 take away p. So what am I doing? 3p plus 1 take away 1 over 9 take away p. Let me see. I'm going to cheat a little bit. It says 3p. I'm just going to rub that out. You don't do that on your exam, of course. You show all working. I'm going to cross multiply. So I do 2 times 3p, which is 6p, equals 27 minus 3p. If I rearrange that, I have 9p equals 27. Divide both sides by 9. P equals 3. Very nice question, I have to say. So well done to all of us solving that. So like and share if it is useful. Check my website explainingmaths.com, and let's move on now to question 8. So we're moving along quite nicely together. We're at question 8 now of this past paper. And like and share if it's useful, and check my website explainingmaths.com. What does it say? Question 8. The function f is defined by fx equals 1 over x plus 1 plus 1 over x plus 1 squared for x greater than minus 1. And the first question for 3 points is find the derivative. What differentiate the function with respect to x? Oh, there, those are emails. Sorry about that. So how do we do that? Well, first of all, let's rewrite it. I'll squeeze it in here. Before I find the derivative, I gotta put it in the numerator. So I'm going to say that's x plus 1 to the power minus 1 plus x plus 1 to the power minus 2, and then I can differentiate it. I'll do that here. Apologies, I don't have a lot of space, but the derivative. So it is going to be minus 1 times 1, which is minus 1. Brackets stay the same. And then 1 less than minus 1, so that becomes minus 2. And then times the derivative on the inside, because that's a chain rule if you like, but the derivative on the inside is 1, so nothing will be changed there. Similar here, minus 2 times 1, so that will be a minus 2. Brackets stay the same. Then 1 less, so to the power minus 3. Careful there, minus 3. 1 less than minus 2 is minus 3, not minus 1. Times the derivative on the inside, which is 1 again, so nothing changes. So actually, that is my derivative. I could write with positive index notation, however, they do not ask me to do so, so let's just leave it like that. State with a reason whether f is an increasing function, a decreasing function, or neither. Okay, increasing when the gradient is positive, decreasing when the gradient is negative, or neither when it is everywhere. So what can you say about this one? This is the gradient function, the derivative. Well, because of those negatives, it will always be negative, because you have, whatever you plug in for x, the value of your derivative is going to be negative. So you're going to say it is going to be a decreasing function, but you have to stay with reason. It's a decreasing function because the derivative is always negative, like that, smaller than 0. There you go. We continue. The function g is defined by gx, 1 over x plus 1 plus 1 over x plus 1 squared. So it's the same, but now for x smaller than minus 1. Okay, find the coordinates of the stationary point of the curve y equals gx. So a stationary point, what is a stationary point? That's where the derivative, where the gradient is 0. So you might want to just start with that, showing that you understand that. You're looking for dy dx has to be 0. Now you already found the derivative for part A, so we're going to use that, but now I'm going to write it in positive index notation. So x minus, I'm looking at the wrong one. This is the derivative, that was the original function. This is the derivative, so we're going to use that one. So minus 1 over x plus 1 squared, so that should be in brackets, minus 2 over x plus 1 in brackets to the power 3 equals 0. So we're going to find out now for which values of x is the derivative 0, because that's where you'll have a stationary point. Several ways of doing this. I'm going to combine the fractions, so I'm going to multiply this one by x plus 1 to make sure the denominator is the same. So I'm going to say times x plus 1. So what am I going to get then? I'm going to get minus 1 times x plus 1 over x plus 1 to the power 3. That's why we're doing it. We'll leave this one as it is. X plus 1 to the power 3. And we're still looking when is that 0. And if I combine that as a single fraction, x plus 1 to the power 3, the numerator is going to be minus x and minus 1 minus 2. So is that right? Minus 1 minus 2, so that is minus 3. There we go. Okay, so when is that 0? Well, when is a fraction 0? That's when the numerator is 0. So for this to be 0, minus x minus 3 needs to be 0. So minus 3 equals x. So x minus 3. So that's the x coordinate of your stationary point, which is also less than minus 1, so that's good. But they're asking me for the coordinates, so that's the x coordinate. We're interested also in the y coordinate. And how do you find that one, the y coordinate? Like you've done for many years now, you plug it in the original function to find the corresponding y value. So 1 over minus 3 plus 1 plus 1 over minus 3 plus 1 squared. what is that? Minus a half. That's then becomes positive a quarter, so that is then minus a quarter. So the coordinate of my stationary point -3 minus a quarter. Excellent. I hope that is useful still. explainingmaths.com for more activities and resources. And let's now move on to question 9. I'll see you there. So we've come to a question about progressions, and it says the first term of an arithmetic, so that's important, progression is minus minus 2222, and the common difference is 17. So every time it's plus 17, plus 17, plus 17. Find the value of the first positive term. Now, of course, I can plug it in my calculator, minus 2222, and just add 17 until I get a first positive term, but that's going to take me a little bit too long. I'm going to find out how many times do I have to plus 17 to get to 0. Let's find that out. So if I have minus 2222, how many times does 17 fit into that? So I'm going to grab my calculator now, and I say minus 2222 divided by 17 equals, and then it tells me minus of course. Let's ignore that negative sign. That doesn't really apply now. So it will fit in 130 times and a little bit more. Now, let's find out what if I add 17 130 times. Yeah? So if I would add 17, so this is my starting number, and if I would add 17 130 times, yeah? So that saves me a lot of time pressing that in my calculator, plus 17, plus 17, plus 17, 130 times. But where will I be then? So minus 2222 plus 17 times 130, that will be minus 12. So is that positive yet? No. So it's going to be the next term is going to be positive, so another 17 added to it. So the first positive term number, or the first positive term, is going to be of value 5. Good, that was for 3 points. Now question B, what does it say? The first term of a geometric progression, so that's geometric, with a common ratio, is square root of 3, and the second term is 2 cosine theta, where theta lies between 0 and pi. Interesting. Okay, find the set of values of theta for which the progression is convergent. Okay, so when it approaches a particular number where it has a limit. Converging progressions, what do you know about that? Well, you know, I'll continue in blue, sorry. You know that the ratio for converging progressions has to be, let's say, a fraction. So it will lie between 1 and minus 1. Okay, and what is the ratio? The ratio is always the term divided by its preceding term. Is that English? Yeah. So the second term in this case divided by the first term. That will be the ratio. And please check my website explainingmaths.com where I explain this in more detail. Yeah, but you should know now that R is the second term, then 2 cosine of theta divided by the first term, which is square root of 3. Excellent. So let's find out now for these two values what the value is of theta, and then we'll see how we're going to deal with that. So let's start with the minus 1. I'm going to find out when is it minus 1. That will be cosine of theta is the square root. I said minus 1, didn't I? So minus square root over 2. And if I plug it in my calculator, and it says, by the way, between 0 and pi, so I make sure I set my calculator to radians. I should always start with that, otherwise I might forget. But I do it now, so I put it to radians, and then I get 5 over 6 pi. Excellent. And that lies within the domain between 0 and pi. There's not another value in that domain, which is going to give you the same cosine. So for the other value, so we've checked minus 1 now. Now for 1, so I'm going to ask now, when is it 2 cosine of theta over the square root of 3? When is it 1? So cosine of theta equals square root of 3 over 2. And if I plug it in my calculator, the inverse shift cos square root of 3 over 2 equals, I get a sixth of pi, or pi over 6. Excellent. Find the set of values for which it's convergent. So what do you have to do with that? Theta, well, theta has to be bigger than pi over 6, but smaller than 5 pi over 6. Okay, so those are those two angles. Excellent, that's your final answer. Very nice question, I have to say. Let's move on. Question 10. We're almost there, guys. I see you there. Yes, we were expecting a question like this, with a curve and perhaps calculating the area underneath a part of that curve. So this is no surprise. Let's see what they're asking. They say points A29 and B30 lie on the curve y equals 9 plus 6x minus 3x squared as shown in the diagram. The tangent at A intersects the x-axis at point C. And you have to show all necessary working. So just before I start, I have a curve which and a tangent, but that point C is a part of the tangent, not the curve. Okay, that's important because it's slightly confusing. Yeah? But point B is part of the curve, C is the tangent. What are they asking? Find the equation of the tangent AC and hence find the x-coordinate of C. All right, the equation of a tangent. You've done it many times. Y equals mx plus c. That's the notation I prefer. You may do it slightly differently. But what do I need? I always need a coordinate. Well, they give me a coordinate 2, 9. Let me just write it down. 2, 9. Because I need that coordinate to find the y-intercept to find c. But I also need the gradient. And how can I find the gradient? Well, I can take the derivative of my function. So f prime x equals, what is that, 6 minus 6x, and I'm going to find out, so what is the gradient at that point where x is 2, because that's going to be the gradient of my tangent line as well. Yeah, and please, I explain this in more detail on my website, explainingmaths.com, so check it out if you need more help. So the gradient is minus 6, so y equals minus 6 plus minus 6x, I should say, plus c. And to find c, I substitute that point 9 minus 6 2 plus c, so 9 minus 9 minus 12, so 9 plus 12, so c will be 21. So the function, or the equation of that tangent, y equals minus 6x plus 21. Now again, I'm very used to writing it in a gradient intercept form, but you might be used of writing it like this: y minus 9 equals minus 6x minus 2. You do that's the same answer. You do whatever you want, okay? As long as you have one of these two answers, they're equally as good. Excellent, that's for 4 points, very nice. And no surprise. Also for question II, it's not a surprise. For 5 points, find the area of the shaded region. Now there's several ways to approach this. What am I going to do? I'm going to break it up. Yeah, first I'm going to look at the area underneath that tangent, which is a triangle, like that. See that? Oh, sorry, hang on a minute, I'm not finished yet. Yeah, but that reminds me, and I should have underlined that, find the x-coordinate of C. I forgot to do that. What is the x-coordinate of C? Well, the x-coordinate is always where the y is 0. So I'm going to check it out now, evaluate this function for y is 0. So 0 is minus 6x plus 21, so 21 divided by 6, what is that, 3.5, so x equals 3.5. Ooh, I almost forgot that. Luckily I noticed it for the next question, yeah, but I should have underlined it to start with, because you know you're going to forget small things like that. Find the area. So again, I'm going to find the area of the triangle, and then I'm going to subtract the area of the triangle with the area underneath the curve. Yeah, between this point and that point. And this point, the x-coordinate is 2. Okay, so first the area of the triangle. So the area of a triangle is half base height, where the base and height make an angle of 90 degrees. So that would be this times that. So what is the height? It goes from 0 to 9. And what is the base? It goes from 2 to 3.5. So that's 1.5. So 9 times 1.5 or 1.5. I'm going to grab my calculator now. 9 times 1.5 equals, divided by 2 is 27 over 4. Excellent. So that is the area of that entire triangle. Now I'm going to find the area underneath the curve, and you use integration for that. You know that. So what are the boundaries? It goes from 2 to 3, not 3.5, because that's a tangent. No, from 2 to 3. So 2 to 3, and what is the function? 9 plus 6x minus 3x squared dx. Yeah, so I find the integral of that. 9x plus, that one will be x squared, so 3x squared, and that one will be x to the power 3, so 1x to the power 3. That's it. And we're going to check that for 3 and 2. So first I'm going to substitute 3 inside my integral, and then take away, I'm going to substitute 2. So let's do that. So if I substitute 3, 9 times 3, I'll just put some brackets there, and I'll put a line here. Sorry for the mess, guys. But anyway, 9 times 3, 27. 3 squared, 9 times 3, so plus 27, minus 3 to the power 3, so that is minus 27, minus, and I'm going to substitute 2 inside, which is going to be 18, let me see, plus 12, is that going to fit? Minus 8, I believe, is that correct? Minus 8, it is, alright. So what is the area underneath the curve? That's going to be 27. Take away, what is that, 30, 22. So the area underneath the curve is 5. So what is the area of the shaded region? Is going to be 27 over 4. And the area of my triangle, take away 5. Now I'm getting a little bit tired, so I'm going to grab my calculator. 27 over 4 minus 5. It tells me 7 over 4. Fantastic. Very nice question. You expect these questions, so you can prepare yourself for it. So no surprise. Let's go to question 11. I'll see you there. So we've arrived at the final question of this AS Pass paper. And I'd still like to say again, please like and share if it was useful. And check my website explainingmaths.com. In this final question, I see a sector, a part of a circle, and there's like a right angle triangle in the middle. And I can see here we're talking about radians, so make sure your calculator is set to radians. What's going on? In the diagram, OAB is a sector of a circle. Center is O and the radius is R. And point C is an OB such that the angle ACO is a right angle. Angle AOB is alpha radians, and it is such that AC divides the sector into 2 regions of equal area. Okay, that's interesting. So the area of, let's say, this part equals the area of that part. Excellent. Now what is the question for 4 points? Yeah, so that's some work is going to be involved. Show that the sine of alpha times the cosine of alpha equals a half alpha. Okay, yeah, there's a lot of information. What can you do? What are they telling you? They're not telling you a lot. You don't know any values. It's an R, it's an alpha, that's it. But they did say that those areas are the same. And at this stage, I have no idea what the answer is. But that doesn't mean that I cannot start. Because write the things down that you do know about this question. Because what did you learn? You've learned something about finding the area of a sector. And you also learn something about finding the area of a triangle. Now let's see how that relates. The area of the entire sector is the angle, so that will be alpha, out of 2 pi times pi r squared. Okay, there we go. And if we simplify that, and some of you do that straight away, you see that the area of the entire sector is going to be half alpha times the radius squared. Okay, so that's of the entire sector. Now the area of this triangle is going to be base times height divided by 2. So where the base and the height make that 90-degree angle. So OC times CA divided by 2. Now what is OC? Well, you can say, because they're talking about sine and cosine, so I've got to find the sine and cosine somehow. Well, I know that, let me do that in black over here. I know that the cosine of alpha is the adjacent, so OC over the radius. So is OC over the radius. So OC is the radius times the cosine of alpha. Okay, so let me write that there in my diagram. It's a little bit tiny, but it's radius cosine alpha. And I do a similar thing for AC, but then standing in my angle, it is actually the sine of alpha will be AC over the radius. And if I rearrange that, the AC will be R sine of alpha. Yeah, excellent. Yeah, so I found my cosine of that sine. I'm going to do something with that now to create this particular equation. So what is the area of that triangle? That will be r. So the triangle is going to be r cosine of alpha times r sine of alpha divided by 2. Okay, that's the area of the triangle. Excellent. But how do they relate? We said that this part is the same as that part as the area. So you can say that the entire area of the sector is twice as large as the area of the triangle. So I have to multiply the area of the triangle by 2, and then that should equal the area of the sector. So the area of the triangle times 2. So now I can say that r cosine alpha times r sine alpha has to equal half a radius squared. And then if I take out the common factors, r, that's an r squared and an r squared there. Yeah, so I can say, so therefore the cosine of alpha times the sine of alpha equal half alpha. Okay, that should be an alpha. There you go. Good, so I've showed it. There you go. So again, I didn't see that when I started with the question, so do not focus on the things you don't know. Look at the question, analyze it. What do I know? Well, I know sector area, I know the area of a triangle. Let's see how I can connect those two pieces of knowledge to answer that particular question. Okay, then they continue. It is given that the solution of the equation in part I is that alpha is 0.9477 radians, correct in 4 decimal places. So we know now the value of that angle. Find the ratio, the perimeter of OAC. So the perimeter of OAC as a ratio to the perimeter of the region ACB. Okay, so that second part. All right, for 5 points. Again, doesn't mean it's difficult. It just means that you'll have to do some work. So let's find the perimeter of OAC first. OAC, and that's why it's useful that I put those values there at the beginning, because the perimeter is going to be r cosine of alpha, r cos alpha plus r sine alpha plus r. And if I then substitute that value of alpha, so I do the cosine of 0.9477 and the sine of 0.9477, please make sure your calculator is set to radians. And then you collect the like terms, then you'll have 2.4 r. Okay, so that will be the perimeter of OAC. I'm going to do a similar thing for ACB. So what is for ACB? Let me put it there. ACB. There we go. So the perimeter is going to be r sine of alpha. Let me write that down. R sine of alpha plus. And then this part is the radius, take away r cosine of alpha. So I'm going to say it's going to say radius r take away r cosine of alpha plus, yeah, so those are 2 parts. Now I have part 1, r sine alpha, part 2, this is the radius take away r cosine of alpha. And now that part, which is an arc, it's a part of the entire circumference. And how do you find that? Then you do the angle out of 2 pi, if we talk about radians, times 2 pi r. And then, yeah, you can simplify that. So some of you may say, well, that is alpha times the radius, straight away. Okay, that's good, but I don't like to remember those things. I always still write it down, alpha over 2 pi times 2 pi r, and then I will take out the common factor, because then I'll never make a mistake. Again, we can now substitute the value of alpha inside the equation, and then collect the like terms. And then if you do that, and I've just done that just before this video started, you're going to get 2.18 r. Okay, so that will be the perimeter of ACB. Now they're asking me for the ratio. Yeah, I've got most of those points in now. They're asking me for the ratio OAC as a ratio to ACB. So to find that ratio, I've got to divide, but make sure you do that 2.4 divided by 2.18, because the order is also important, and that is, let me check that, 2.4 divided by 2.18 equals, that will be 1.1. 1.1. So the ratio is going to be 1.1 to 1. There you go, that's the final answer there. Great, the final question of the exam for 1 point. Doesn't mean it's easy, but it just means that it doesn't involve so much work. Find angle AOB in degrees. So we know it in radians. So how do you go from radians to degrees? Well, I'll do it here at the top. So I'll do question I over here. How do I do it? Again, there are perhaps better ways, but I like this. Pi I write down is 180 degrees. But I don't have pi, I have 0.9477. So to go from pi to 0.9477 radians, I first divide it by pi, then I have 1, and then I times it by 0.94777. So I have to do the same 2 steps with 180 degrees. So I'm plugging in my calculator now, 180 divided by pi equals times 0.9477, and then that to 1 decimal place is 54.3 degrees. Excuse me. Now I'm sure that that maybe you can do it quicker, or you have learned some sort of formula to convert radians into degrees and the other way around. But I always just like to work it out on the spot, so I don't have to remember anything. I know exactly what I'm doing, so yeah, I don't like remembering. Excellent, that was the entire paper, an entire AS paper. I have to say I'm a bit tired now, it was a lot of work. I hope it is useful, and like and share it. Check my website, explainingmaths.com. I do appreciate it if you would do that for me in return. And I wish you a very pleasant day and all the best, and even try to enjoy your exam a little bit. Read the questions properly, evaluate your answers, show all workings, and focus upon the things you know rather than the things you don't know, and realize the exam is your opportunity to show all the things you've learned, and it's not the examiner's opportunity to tackle you or to make your life miserable. No, examiners are nice people. They want you to pass, they want you to do well. So keep that in the back of your mind. Just show the workings and have confidence in yourself. Excellent. I wish you a pleasant day, and I'll see you later, and all the best. Bye-bye.